First of all, I want to thank everybody for taking time out of their busy schedule to watch this webinar. I hope you got a lot of good information out of it. You know, I always tell people that if you watch it, you usually need to watch it more than once. And if you can pull one nugget of information out of it, you've done well. There's a ton of information there that Howard presents, and just watching it once does not allow you to absorb it all. For those of you who don't know me, my name is Jason Spangler. I'm the flooring division manager here at Wagner Meters. I'm responsible for both the Rapid RH and for the small line of hand meters that we have for testing wood, finished floor products, and subfloors. We're going to go through a Q&A, so if you have any questions, please type them in, send them to me directly via email, and I'll get to as many of them as possible. If for whatever reason you do think of something after the fact, or if you need to get a hold of us, please contact me directly. My phone number is 800-634-9961, and my direct extension is 235. So with that, we'll get to the questions. One of the common questions that I get is regarding how to determine how thick the slab is. And if we're talking about a slab on grade, you know, obviously there's building specifications, there's construction documents, things of that nature that you need to go off of. Rehab projects, there's a lot of times where there's trenching being done to move plumbing, electrical, things of that nature. If you can get in early enough to see the profile of the slab at that point, that's a good thing. Worst case scenario, there are a couple of different options. One is there is an instrument out on the market that is available for purchase that will allow you to determine the thickness. You can actually put it on top of the slab. It's based off of what they call an echo impact principle, and it will allow you to come up with a thickness of what that slab is. It does have a plus or minus error to it. So it's not going to be absolute, but from what I've seen, it is definitely good. Downside to it is that it's still, I think, about $2,500 to buy that. And so for most people, that's not usually a practical application or a practical device to have. So what you see people doing out on the job site is they will take and drill, they'll take a smaller diameter drill bit, they'll drill a couple of smaller holes all the way through the slab. Again, different areas of the building, just so you can get some kind of comparative information to look at. Once you drill the holes, they'll use a pliable wire, make a J in the bottom of it, push it down through the hole, so that when the J is actually fully out, as you push it through the hole, it collapses a little bit, push it all the way down. When it gets to the bottom, that J will pop back out. You pull it up until you feel resistance, mark the top of it off the Sharpie at the top of the surface of the concrete. And then as you pull it out, you can see where the radius was in the J, compare it to where the Sharpie mark is, and it gives you something to actually look at as far as thickness goes. Again, they're not turning the slab into Swiss cheese. They're definitely going to just do a couple of holes. They're going to fill those holes back in with either an epoxy or some kind of cementitious product to make sure that it's filled in. But that gives them the ability to have done their due diligence for thickness. Now, when you're talking about, it leads to the second question. When you start looking at pan decking, it's not as much the thickness of the pan decking as much as it is the overall, where do you place, or what dimension do you use to calculate how deep to put the sensor. So first of all, with an elevated slab in pan deck, it's still only drawing from that top side. So your calculation is going to be at 40% of whatever number we come up with. So as opposed to if you have something that's elevated and drawing from both sides, it's going to be at 20% of the thickness of that slab. But with a pan deck, the ASTM standard is really silent at this point on how to specifically calculate where to put the sensor or what depth to calculate it off of. So with a pan deck, you're typically looking at, a common one is in the shallow, there will be 2.5 inches of concrete. In the deep, there might be 5.5 inches of concrete. couple of different ways that are being done out there that people are installing these things and where they're installing them. One, for less than $100, you can pick up a metal detector that will be strong enough that it will pick up the high part of the metal hat in the pan decking. So you can scan it across the surface of the concrete, just like you would a stud finder in a wall. Scan it across, pick up the high spot of the metal hat, mark it, scan across further, mark the other hat, and then in between those two is going to be 5.5 inches thick, and you're going to base your drill depth on that 5.5 inches. So you're going to go 40% of 5.5 inches in the thickest part of that pan. The other way that some people are doing it is they're doing an effective thickness calculation where they are taking the 2.5 inch thickness and they're taking some variation of the remainder of that slab, adding them together, and then coming up with a number that will allow them to drill anywhere on the floor. Neither one of them are in the ASTM standard specifically, but I can tell you that that's a couple of different ways that people are actually doing it out in the real world. Hopefully, because the committee for the ASTM committee is actually looking at this and many other things, hopefully it'll be something that's addressed specifically in the standard at some point very soon. Okay, so without any further ado, I want to again thank everybody for being here today. If you have any questions, please don't hesitate to call us. Phone number is 800-634-9961, and it's extension 235. Thanks, and have a great day.